Hi, and welcome to this video, the second video on arithmetic sequences and series. Okay, so a long time ago, this mathematician in the top left, his name is Gauss. He was famous for writing a formula for the addition of consecutive numbers, like the numbers 1 to 1,000, 1 add 2, add 3, add 4, and coming up with a way of doing it quickly. Now, legend has it that this mathematician here is quite frustrating for a teacher to teach someone so brilliant, and we're actually talking about when he was 7. So this was a task basically given to him to just keep them quiet so they could teach the normal children, basically. And it's reported that in a matter of minutes he came back not only with the answer but a method of doing it. It's pretty awesome, and we're still talking about it now and using it all the time. So let's just dumb the problem down a bit, and look at the first 10 numbers. So I'm going to call it S for sum. So what we're asking is, what is 1 add 2, add 3, add 4, plus all the way up to the first 10 natural numbers? Well, when you start doing it, it's not too difficult. It takes time. But what this 7-year-old mathematician realised is if you did it backwards, something happens. Now, obviously you're going to get the same numbers, but when he looked at this, he went, look, can you see the pattern? Hopefully you can, that you get all of these 11s if you add them. So if you treat them like simultaneous equations, add them together, you get a whole bunch of 11s. So that must be, we invented multiplication to stop us having to do repeated addings. So how many of these are we going to have? Well, of course that answer is 10, and we get 110. But this is an S, sorry, that's two S's, isn't it? Because I've added them together. Do apologise. So that's 2S, so then the sum of just the first 10, well, that would be 55. Well, why do we need to do that? It's a pretty easy problem. With 100 numbers, it's just time. So with 100 numbers using the same logic, the pairings, 1 and 100, so we're going to have 2S is going to be 101. We're going to have 100 of those, and then we have to divide it by 2. So let's just do that. So 2S's, what's that going to be? 10100. And if we half that, we get 5050. Okay, so pretty awesome, especially considering that he's 7. So what we need to do, and we'll do it in a minute, is write a formula, which he also did. But before we do that, we need to just understand this language a bit. So a sequence, an arithmetic sequence, is what we were looking at in the first video, commas in between, common difference. A series is the same numbers, but instead of a comma, we're going to put plus, and we're actually going to add them. So a series is when we're adding, a sequence is commas, when we're just looking at that common difference. So you need to be able to do this. So not just understand it, be able to repeat it. So S for sum. Now every arithmetic sequence always starts with an A, and then we have an A plus D, A plus 2D, plus dot 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 A plus N minus 2D. Just going to shrink this down a bit. Oh, what happened there? That's awful. There we go. Plus A plus N minus 1D. Okay, that's just a general formula. Well, what did we do with the basic number form where we just did it backwards, yeah? So we had S equals A plus N minus 1D plus A plus N minus 2D plus A plus N minus 3D dot dot dot, and we had A plus D, and we had an A. So we know that these pairs add up to the same value, and you'll probably find it easier just to look at the first or the last to work out what that value is. So if we add them together, we get two s's, well, a plus a, which is two a's, plus n minus 1d. Well, how many of them are there? So if there was 10, we times it by 10. If there was 100, we times it by 100. So obviously we're going to times this all by n. So what we should do now is put this all in one big bracket because we're timesing it by n. And mathematicians are generally happier when this multiple is at the front. So something like this. But that's for 2s. So I can divide both sides by 2, and I could put a big line under, or I could just half this term, or I could half the bracket. It'd be easier to do that, and this is therefore the formula. So I'm just going to put a little n there, sum of n. You need to be able to do that, and just, can you see how I've done it with the pairing? So I've got the first three and the last two. You could do the first three and the last three. I wouldn't skip any, what I've done. So, yeah, just like that, it's perfect. But there's another way we could look at it as well. Because what are we actually doing in this red bracket here? Well, we're doing first plus last. So instead of writing all of that, we can just write it like this, first plus last. And this latter formula is going to come in particularly handy if you have the last term. So let's have a look at some. So this is a particularly easy question. You know, you could do this at GCSE, no problem. Find the sum of the first 50 terms of the arithmetic sequence. So what do we know? Well, we have a. We have the common difference to be minus 5. But we don't know the last. But we know there's 50. So we could work out the 50th one. But let's see how we go. So the sum of 50 terms is n over 2 lots of 2a plus n minus 1d. So 50 is n, so let's pop that in there. So we're going to have 25. Lots of 64 plus 49 lots of minus 5. And it's as simple as putting that into a calculator. And I believe you get minus 4,525. So the sum of this is actually negative because you can see it's very quickly going to become below 0, maybe 2 more terms, and then you've got shed loads after that. Well, how else could we have done this? So we could have found what the 50th term is. So we can see the nth term is minus 5n plus 37. Now if you put 50 in here, so what is the 50th term? So minus 5 lots of 50 plus 37. What's that? Minus 213? So the 50th term is minus 213. So sum of 50 is 25 n over 2 first plus last. And if you work that out, you get exactly the same answer. So 2 methods, either way is fine. Okay, so find the least number of terms required for the sum of this series to exceed 2000. So what we're looking here is, how should I write this? N over 2, 2a plus n minus 1d, and that's got to exceed 2000. Right. So sometimes it's easier to solve this problem if you just put in equals here. So when will it equal 2000? And then obviously you've got to go to the next term up for it to exceed it. So let's have a look. So we don't actually know what n is, that's the question. So we've got n over 2, 2a's, 8. So we've got n minus 1, and we've got 5 there. And we're exceeding 2000. So the first thing I'm going to do is, well, I'm going to do 2 things. I'm going to get rid of this divide by 2 by multiplying both sides by 2. This is just one term here because it's being multiplied. So that's going to be 4,000. And I'm going to expand this at the same time. So 5n minus 5. We need to tidy it up. So 3 plus 5n is greater than 4,000. Expand. I'm going to pop it this way. And because I know it's a quadratic, I'm going to just bring everything over, save a little bit of working. Now it's just a matter of putting in the quadratic formula. This is where I realise I haven't got a calculator with me. So, yeah. Well, I'm going to hand this over to you now, guys, I'm afraid. But if you pop this into the quadratic formula, whatever you get there, that's what it's equal to. Just please remember it has to exceed 2,000. So, for example, if you got 24 here, that's when it equals 2,000. You got 25. It's quite likely to be a non-exact answer. So let's say you might get something like this. That's the 3 sig figs. So that means on the 24.2nd term, it equals 2,000. So it'd be the 25th term. Oh, this one's got loads of writing on. Let's get rid of that. Now, crikey, this one looks a bit of a challenge. So this time we're going to have to find the sum of all of these. This is pretty neat because we have the last and we have the first. Now, the only problem I'm thinking of here is with the formula there's n's in it, and you can see there's no formula, so I might have to go for the first plus last. That's another way of getting rid of all the n's. Let's see how that goes. So sum of the n, well actually no, there always hits it, n over 2 plus a plus last. So what have we got? So we've got n over 2 lots of k plus 2 plus 300. So n over 2 is k plus 302. Okay, well, I've got k's, but this n has to go. So eventually what will happen is this should turn into this part here. So how can we find an n? Well, let's try and work out what term this is. And we can do that using the nth term formula. So un equals a plus n minus 1d. So 300 is equal to k plus 2 plus n minus 1 lots of the difference, which is, right, let's have a think. Every time we're getting an extra k and we're getting an extra 1, so the difference must be k plus 1. So we've got k plus 2 plus nk plus an n minus a k, and my last terms give me minus 1. So k's are cancelling. 2 take away 1 is 1. So we've got 1 plus nk plus n is 300. Okay, so I can definitely get n. So let's pop that on the other side. Let's factorise for n here. Alright, so factorise, divide, just making n the subject. So let's just pop that in here now. So I just changed colour. Let's go for like a purple. So n is being halved. So dividing by 2 is the same as timesing by a half. So if I times this by a half, this is basically what I'm doing. So it's going to be 299 over 2k plus 2. Right, that makes me happy because I've got the denominator, so this should be fine. And I've just got to times that by k plus 302. Right. It's a little bit worrying. Oh, that's strange. Let's get rid of that. So if I times this, I don't get the question. But I can see I made this question up, so I may have got it wrong. So 299k all over 2k plus 2 plus, crikey, what's that? Just pause it quickly. So that is 90298 over 2k plus 2, which equals 299k plus 90298 all over 2k plus 2. Guys, that's wrong. When I paused it, I just had a quick look at it again. There's no mistakes there. That's just a bad question. That's the answer. Okay, so if you get anything like this, then just start off with what you can normally do. You'll get stuck. You compare your answer, what's missing, or what do I need to remove. Find a way of making that the subject, sub it in, and you're good to go. Okay, best of luck, get practicing.